This is a recording for CSC 249 data structures, February 1st, 2006. All right, there we go. This is your instructor. I think I still have snow on me. So we'll go back to the bot. All right, let's look at our code here. Oh, fantastic. We lost our entire page here. So let's get back to that. Course. There we go. Great. Okay. The assignment is posted here under Module 1. I'll go back to Canvas in a minute to show you. Pretty much what I want you to do is to work through this. You can sort of just watch the video, but I want you to run the code and try it yourself. So I provide a little bit of a lecture I'm going to talk through with some slides. I give a quick demo, and then I give you either the C++ program or the Python program. And it's marked with to-dos. I want you to finish it. I feel like this is not going to be too complicated, but we'll walk you through it. And the reason we're doing this is to get you used to writing code in our environment. I'll make sure we've linked the GitHub code spaces. That'll be a useful thing to have. I personally like to use GitHub Desktop to organize myself. So I'm going to open up my repo here and look at this folder. And sure enough, here's my assignment. Okay. What I want to do is give you these slides, and we'll kind of talk about this. You can, of course, go through these on your own. What's the problem we're solving? Anytime we work with data structures, we're dealing with an actual customer need. So congratulations, you the student right now, you're the customer. So the problem is you're trying to keep track of your classes. So you're taking maybe calculus, C++, data structures, different credits, they meet at different times, and you want to get organized. So how would you store this information? Well, what we've taught in classes so far would be that we would use parallel arrays, or what you would call in Python parallel lists. Really the same thing. Like I said, I'm going to show you guys that Python and C++ are kind of the same language under the hood. They're not, but they are. So I could have an array with the names of the classes, an array with the codes of the classes, and an array with the credits of the classes. So those are called parallel arrays. If you read up and down, those are different arrays. So if you want to figure out what your third class is, you would pull, index number 2, because it's 0, 1, 2 is the third one. So that's calculus 2 is the name, math 172 is the code, and it's 4 credits. All well and good. What if we then decide we want to sort the information? We have a problem. So when you sort, and you may have seen this in Excel, if you just sort one column and you don't sort the others, suddenly now calculus is called CSC 249. That's wrong. This data is simply incorrect. So when you just store information in order, you can't change the order, which means you can't sort it, which we'll find is a real problem. Being able to sort your data makes it much easier to search through it. Okay, how do we resolve that? Well, we use objects. We create an object in either C++ or in Python called a course. And that course has fields, which are simply variables it contains, such as name, code, and credits. And then whenever you organize those, you just make a list or an array of courses, and you could sort those all you want, and the data inside does not move. Fundamentally, this is not super complicated. I wanted just to break it down to a really simple problem that breaks really messily so we can have a nice little elegant fix. And the way I've described things, if you ever see one of those cake pans that looks like a giant donut, the Bundt cake pan, right? What is it? It's a piece of metal that has air inside. When you bake a cake, you get the opposite. You get a negative. So everything that was air is now cake. And the metal is what is the surface of the cake. In the same way, a class is a blueprint. So, that blueprint, that cake pan is the blueprint of the cake. And when you make a cake, it's very similar, but it's not the same thing. So we define a class blueprint saying what data it's going to hold. In this case, the class is a course. It's going to hold some information about the courses you're taking, which would be name, code, and credits. And then we make individual cakes or objects, in this case courses, and we fill them in with the data here, giving them the correct name, the correct code, the correct credits. This looks a little funky, but it's reasonable to work with. So my font sizes got bigger, got kind of messed up here. So the idea is inside an object, you have state, name, string, credits, instructor, right? But then you have behavior, which is these functions, get name, set name, get credits, set credits. Why do you want to do that? Because, well, let me give you a great example. A class FA Voltaic cannot have an empty name. We must name the course something. So in set name, I would not let you set the name, or it would make sense to not set the name if it's empty. If it's link 0, that's not a valid name. Maybe you can't have negative credits. That would be bad if you could lose credits from taking classes, right? So there's things for validation where you would say these things are true. And then there's this property down bottom called toString, which is going to print out the class in a human readable format. Okay. In the same way, we're saying state and behavior. So I describe this often as nouns and verbs or variables and functions, but state and behavior is good. I have a dog. Her name is Esther. She weighs 69 pounds. She has behavior which involves seeking food and going for walks and getting petted. That is an individual instance of the dog class or the mammal class, depending on how you want to define things, right? So internal state is information about that object, whereas behavior may be more general, right? So any dog can bark. Any mammal could make noise, probably. But those are activities, whereas the particular noise they make or the particular food they like would be internal state, internal variables. In the case of a course, the information we think about being part of the course, CSC 249, the name is data structures, number of credits, I believe that's 4, right? Those are all state, and behavior would be things like get name, get credit, set credits, toString to explain that. And when you put it all together, you get an object. So you get this nice little bundle that can do things and also holds its own information. And we care about that because by having what's called encapsulation, by having these setters, you can prevent bad data, or at least reduce bad data by saying, no, you can't set that value to something we know is not true, right? The classic example I always give when we're doing receipts, because I worked a little bit in retail in high school, was sales tax. If you don't collect sales tax, the government will still require you to pay it. So you really want to make sure your sales tax numbers in your program are correct, right? So being able to set your sales tax to 0, probably not good. You're going to still owe that money. So in the same way here, if the course has the wrong credits, we just don't allow it to be set. Now, when you work on the program, I'm not going to require you to do validation in your getters and setters. You can just write the getters and setters. But that's okay. All right. And if you think about how this works internally, it's very simple. If we're not doing validation, you've got a function called getName, and it returns the name. Okay. Now, if you think about that in whatever language you're working with, it's returning a copy of the name, which means when I call getName, if I change that variable, it doesn't change the original object, right? I'm just getting a copy of the information out of it. I can print that, do whatever I want. If I call setName, I can change the name of the course. I probably won't do that often, but it happens every few years. And then that'll be updated in that new version. All right, so here we see calling a constructor, which is simply the information you pass in. The idea being if I need these fields to be true, I need these fields to be valid, they have to be filled in, then I'll just go ahead and provide them all when I create the object. And then there's finally the toString. Probably your print for Python is just going to, you can just print any arbitrary object. It looks kind of okay. And we'll see how the toString looks. Now, there's definitely things you can do where you make your strings look better in different situations, but this is a good start. All right, got a couple of differences here for the two languages. I'll just leave that up for a second to think about because, you're used to one of them already. The other is going to be very familiar soon. I know the Zybooks examples are in C++. I'll be providing Python examples to go with that. All right, so what's your actual assignment? Keep it short. You need to add the getters and the setters. You need to add toString, and then you need to run the code and see if it works. And I would recommend you create the objects, use your actual classes. So put in the actual class name, the code. You can find out the number of credits if you go to self-service. I'm making you do a little research to find out what you're doing. And you're going to turn in these two files. Great. Why are we doing this? Because we're making what's called sort of an individual node. If I want to put information and organize it, I need to have, a fundamental atom. And a node here, a course here, it has everything about a course. So if I wanted to make a list of courses, though I could do that different ways. I could have a tree of courses saying, well, you must take this class first, and here's the prereqs. Now you can take these other classes in this order. There's lots of different ways we can organize things, but getting used to classes here is going to help. All right, let's play the demo while we're here. And I've got that in my repo, so let's just go back to there. And I put it in module 1 demo. And it's simply a page. So we'll load that in a new browser. Let me let Chrome open up, and I'll just walk you through this demo. Great, thanks. You can stop showing me stuff. Good. So here's the example for the presentation that we gave. So you can see here, I could just create my 3 different arrays or lists. It's an array in C++, it's a list in Python. And then when I sort the names, look what happens. It's jacked up, right? Because these no longer match. I'll put that back and it's fine. But in this situation, because each of them is contained within an object, when I sort them, it doesn't matter. All the information stays together, okay? And that's simply what I wanted to show you. So you'll be working with this code. If I go back into the assignment, let's look at the Python code first. Here we go, fantastic. I'll just open this up in my editor of choice. Really, I'll use VS Code. That's not my editor of choice, but that's the one that popped up. Yeah, I'll need to turn on my Python interpreter a little bit later. So let's look at what I have here. So we've got a test file. These are test files. So really what I want to look at first is my main and my course. So this gives me the course, and it tells me all these things and tells you what you should make. Now I will recognize, because I wrote to-dos here, yes, I know you can get the bot to write this code. I'm not asking you to get the bot to write this code. I'm asking you to write this code. This is a thinking exercise, and it's actually not a lot of thinking. So if you hand this off to the bot to think, it's over. You're cooked, okay? Just do the assignment. It'll take you probably 15 minutes. Running the program here, you can see some examples were created. You can create more objects. So you're creating a few objects, you're calling some functions. There's all these to-dos, probably scarier from the to-dos, but I don't think this program will take you more than like an hour to write. Let's look at the C++ version for comparison. Again, open these up. Do you know what? This is going to annoy me, so I'm just going to use my actual editor. Okay, right here. Good old Sublime Text will show me what I want. Okay, I'll go to the course first. In my C++ version, it decided not to use using namespace standards, so we see a lot of std::. But if you think about it, this code does not look that different from the Python. Okay, yeah, it looks a little different, but you can see it's doing the same thing. You've got these functions, and they return things. So the function, this is easy stuff. It's already set up for you. And then when I look at main, tells you how to build it, and it tells you how to add this. So again, I feel like this is not going to be too complicated. I think you guys are going to be good. Let's just remember what the purpose actually is here. I want you to run those programs, give me a screenshot to confirm they work with your classes, with the actual instructor names or whatever. Like I said, you can get that from self-service. And the next thing after that is there's some Zybooks reading. But like I said, you've got a week for this, so I think it should be pretty straightforward. If you have any issues, please contact me. And as always, thank you for your cooperation.